Welcome back, guys. This is part 4 of our C programming tutorial video series. In this part of the video, I'm going to tell you how to print variables in C. And also, I'll be telling you what is a format specifier and how you can use format specifiers to print values of variables in C. Okay, then let's begin. Okay, let me start with this program. Say, for example, you have a program like this, main, and then you know this basic structure, right? If I write something like, this, then you know what you know that this is a valid program now, right? I mean, how it works and all. Now, say, for example, you have declared a variable. Now, you know what is this, right? When I say you have declared a variable, this is a declaration actually. Okay, so you created a variable, say, for example, a, and then say, for example, you have stored there the value 90. Okay, and your task is now see, your task is now say this is your output screen. This is your output screen. Your task is to display the value of the variable that is 90 on the screen. This 90 you have to display on the screen, and that is your task. Okay, and that is what the program should do. Okay, so if I ask you to write that program, then up to this point there is no problem. The first thing is you have declared the variable, then you have stored 90 in that variable. And just for a recap, like that I said you in the previous video, when you execute this program, then in the RAM you should know this thing, huh? When you execute this program in the RAM, it will create a container whose name is A, and in that container it will store 90. Now from here you have to now see your task is to display 90 on the screen. So it means here you have to write something that will actually get the value of this variable A from RAM, and it will display that value on the screen here. Okay, now see, to display something on the screen, you already know how to display something on the screen. Say, for example, you can if you write here like say printf and say, for example, hello, you know that it will be displaying hello on the screen. Like if this is your output screen, then it will print hello on the screen, isn't it? Now that thing, like how to print something from a C program on the screen, you people know that. Only thing is that how you can make this printf to first get the value of this variable A from the RAM and then push this value onto this output screen. How you can do that actually, okay? Or how you can make this printf to do that thing. Okay, to do that, you need to know, like something like this. But first thing is that what are the things that will not work? Say, for example, you might be thinking, why do not I write simply like printf a? Because the value of the variable a is this, so it might print. But what I said you about printf, it prints whatever it is within the double quotation as it is on the screen. So if you try to write something like this, then what it will do is it will print this a as it is on the screen. It will not print the value of this variable a on the screen. Then you might be thinking, okay, if I only need this 90 on the screen, then why do not I do like printf and double quotation 90? Now, why you might be thinking, okay, why am I writing this double quotation? Can I write printf only a? You see, I said like whenever you are writing printf, you must have to provide something within this double quotation. That is the part of the syntax. So if you don't write that, it will be a syntax error. You can try if you want. But the next assumption is like, okay, if I need 90 on the screen, then why do not I display like printf 90? Yes, it will print 90 on the screen. But our goal was not to display 90 on the screen. Our goal was to print the value of the variable a on the screen, right? So if I now change the value of this variable a to 900, then it should print me this time 900, not 90. But if you simply write printf 90, it will always print 90, no matter what the actual value of this variable a is. You get the point? So certainly these straightforward approaches or guesses will not work, isn't it? So now to do that, like now suppose we want to do that, and how do we do that actually? So for that reason, what you need to know is you need to know about these format specifiers. Okay, these format specifiers in C programming language. Now, as the name itself indicates, format specifiers, it means they specify some sort of format. Okay, Now, more specifically, these format specifiers specifies the format of the data that you want to, the format of data actually. Okay, so you can specify these format while displaying values on the screen and at the same time while reading values from the keyboard. Okay, so these format specifiers are useful when you read value from the keyboard. When you read value, I have not said you anything about reading input from the keyboard. Okay, but then also just a future reference, these format specifiers can will be used for both for reading values from the keyboard and for displaying values or outputting values on the screen. Okay, so this is from keyboard and to screen. So in both these tasks, we'll be using these format specifiers. So it seems they are quite useful then. Okay, then let's see now what these format specifiers are. I mean, as I said, no, the name indicates they specify some format of data which is to be either accepted from the keyboard or to be displayed on the screen. Okay, so okay, in that case, what those formats are? See here in C programming till now I have said you four basic data types, right? Four data types I said you. I mentioned four different data types, basic data types, isn't it? Say what are them? Yes, you can like repeat with me. Yes, first is your character data type. This is the like keyword that we use to now specify in our program. Okay, we are talking about a character variable. Okay, same way you have these integer data type, you have these float data type, and you have these double data type. Okay, now for these four data types, for each of these data types, there is a corresponding format specifier. Let me write it here. There is a corresponding format specifier. Format specifier. Okay, what is the format specifier for character? You'll be writing the format specifier as %C. Okay, format specifiers for integer is %d. Format specifier for float is %f, and format specifier for double is %long f. You remember I said you float doubles are nothing but large floating point numbers. Large in the sense, not in the sense of values, okay, in the sense of digits. So that's what long floating point, you can remember it that way. And float f for float, integer, yes, it is sort of like, yeah, d for decimal you can think of, and this character is %c. Okay, now how these format specifiers then we can use to print the values of variables on the screen? That's the question now, right? Okay, now see how we can do that. Say for example, now you see now now that will be done. These format specifiers will be used by the printf. So we need to know something about printf, something more about printf. Okay, now because we already know something about printf, and what we know already something about printf, that whatever we write inside this double quotation, I mean this is the syntax of writing printf, and printf is nothing but it is a function, and that function requires a like a piece of data that you specify within this double quotation. Okay, and see here we know that whatever it is that you write within this double quotation in printf, the same thing will appear on the output screen. Say for example, if I write here dot dot h dot e dot dot, then here dot dot h dot e dot dot will appear as an output. That much we know about printf, right? But also we learned one exceptional cases, you can say like that, and that was like, okay, it is not the case that always it displays everything as it is on the screen. So for example, if I write here now HEL/NOOO, so if I write it in this way and if I try to execute this program, what we know is that it will be displayed like this: HEL. Now this slash n, this is a special symbol. It will not be displayed as it is here. Instead, it will be interpreted as if the user has pressed enter key. So that way the cursor will come at this point. So after that, whatever you print, like the printing will always start from printing will always happen at the place where the cursor is. So after new line, the next character it is to be printed is this O. So it will print like O O O, and the cursor will blink here after printing the third O. So we also know these things. Now see these exception, these like new line character, that this particular character is called as your new line character. This new line character is not displayed, however it is interpreted. Now, the way this new line character is a special symbol for this printf function, the same way these format specifiers are special symbols for this printf function. What I mean is, this printf doesn't display %d as it is. It doesn't display %c as it is. It doesn't display what is that, float as it is, and then long float as it is. Okay, if it doesn't display them as it is, then how actually it displays these these format specifiers? Okay, let's see. So if I write now, it means what? If I write somewhere like, say for example, a cat, A-C-A-T, cat, and then I write here %d is not a dog. Say I write something here. I don't get the meaning of this line. I'm just writing something. A cat %d is not a dog. Now, had this %d been not there, then this particular printf would have printed a cat is not a dog. You know that thing, right? A cat, this suppose you assume that this %d is not there. In that case, it would have printed it like a cat is not a dog. But if these %d is there, then what it will do is actually, you see, these now assume that this %d is there, and we try to execute this particular line. Okay, so what will happen is, okay, what I mean is, so now you assume this %d is there, so it will print it in this way: a cat. Now this %d, whenever printf sees a format specifier, any one of them, okay. So whenever it sees a format specifier, then what it will do is, you can think of, it will leave a blank there. It will leave some space there. It will create a hole there. Okay. Correct. Now a cat %d, now the whole, because it is a format specifier, nothing is to be printed actually here. And then is not a dog. It means what? How these format specifiers are interpreted? They are interpreted as if they are some placeholders. Okay, so there are some placeholders in the text that the program is printing. You can think of like there are some holes created. Now see, when these holes are created, why these analogy of hole is useful. So you can think of like, okay, a cat, then this is this hole because of this %d, and then is not a dog. Okay, fine. And then you see, you are creating some holes, so you have to also fill the holes. So for that reason, whenever you are writing these format specifiers in printf statement, then what you have to specify is, you have to specify, see, the for printf will not end here. It will not end in this way. So how it will be ended with then? In that case, see here, why it will not end here logically? Because these %d's will create some hole, and to make these this printing complete, you have to specify what you want to put in those holes. Okay, so that's the thing. A cat %d, this hole is created, and is not a dog is coming as it is on the screen, whatever you have typed here. Then you know that since you have used only one format specifier, then you will be creating only one hole somewhere. And what you want is here, that's why after closing the text that you want to display on the screen, your text is done here. Okay, this is the text, or this is the set of characters that you wanted to display on the screen, so it is over. Now your remaining task is, you have to fill these holes with some values. And see, for that reason, the syntax is, you have to put a comma after closing the text, and then you have to specify a list of values. As many holes you have created, that many values you have to specify in this list. So for example, here you have created only one hole, you have to specify only one value here. Now only one value here. Okay, now what that value is, so whatever it is the value, if you write here 52, then this printf will print 52. A cat 52 is not a dog here. Now if you put a value here, say for example, say 5 minus 4, then what it will print here, first the computer knows actually whenever you write 5 minus 4, it will do that calculation. 5 minus 4 is equal to 1, and that 1 will come and it will fill this thing. So instead of 52, it will print 1 here. Now see, it gives it gives some, it allows you to create the content that you want to display on the screen sort of dynamically. Because here, see, instead of writing 52 or 5 minus 4, you also can write the name of a variable. Say for example, a. You have a variable, say for example a, where you have stored some value, and then if you specify these here in this list, you specify this variable here, then whatever it is the value of the variable, that will fill this hole here. Okay. Okay, now that much only I have to tell you. I mean, if you have understood up to this point, then using printf with these format specifiers is not going to be a big deal for you. But then also, just to make our understanding clear, let me give you, one or two more examples on this pen and paper, and then we'll be writing some code. Okay. Even if you are a programmer, you have to use this pen and paper frequently. Say, it's a good idea that you practice a programming using pen and paper. That is that some people says, and that if you write something, then it increases your memory. I don't know. Leave that story. Okay. Now, what I want is, say, for example, now let's check our understanding. Say, for example, you have a variable A, and here I store 90, and you have a variable B, and here I store, say, 40. And then I want to display, I write something like this. You just predict what will be displayed on the screen. I write, say, for example, A is equal to, say, percentage D, and B is equal to percentage D. Okay, I write it in this way. And then you see, first thing is you have to know how many. See, why did I put this comma here? Because I used percentage D's here. Okay, so it means what? Up to that point, if the computer has to display these I want to tell you something here. Whatever the thing that you write within double quotation, whatever it is, the set of characters that you write within double quotation, those set of characters as a whole, they are called as string. Okay, I'll be referring to them as string for a time, from this point onwards. Every time I just do not want to call them like a set of characters enclosed within double quotation. So that entire line can be represented by this word, string. So for example, if it is, hello world within double quotation written like this, so I'll be saying that, okay, the string hello world, the string, sorry, I'll be saying that the string hello world. Okay, so you should understand that, okay, when I say the string hello world, it means hello world written within double quotation like that. Okay, that is the like sort of, you should, whenever I say string now, don't get confused what I mean by that. Okay, so now come to the point. Say for example, now this printf. Now, when the printf prints this string on the screen, so it does something like this. It will start from the beginning. So this is your output screen. So it will start from the beginning. The cursor was here, so it will print A as it is because it is not a special symbol. Equal as it is, not a special symbol. And see here, this percentage D. As you know, the printf will not print percentage D as it is. Instead, you can think of, for the time being, it will create a hole there and it will continue. After that, there is this space, and then these A and D space B equal. Up to this point, you should realize that there is no problem. All these characters will be displayed as it is on the screen without any interpretation, without doing any interpretation. Okay, and then after this B, this comes this percentage D. So as I said previously also, that percentage D means it will be interpreted and will create a hole there. Now see here, if printf prints this strings, prints this string, then it will create two holes. So as a programmer, now you have to specify the values of those two holes there. Okay, so what, suppose now I write the holes in this way. Say for example, A comma B. So in this case, what you should realize is that this a, whatever, see here, this a is what? It is the name of a variable where you have stored 10, where you have stored 90. So whatever it is the value of that variable, that will fill the first hole. I mean, they will be, in the sequence. The first hole will be filled up with the value of the, with the value that is specified in the, that you specified first in the list. Now the second hole is this, and the second hole will be filled up with the, second value that you specified in the list. Now see here, this part after the comma, whatever you write, I said that is, I'm referring to them it as list of values. Okay. Now see, as many holes you have, that many values you have to specify in the list, and the list is a comma separated list. Okay. So these things, if you remember, then done. I mean, most of the things are done. Now most of the things are done in the sense that you see here, I said you about percentage D. So if you might be thinking, if I can do everything with this percentage D, then why do I need this CFLF? And not only these four, there are like a few more, these format specifiers are there. But for the time being, for most of the initial programs, we'll be dealing with only these first four format specifiers. But you do not need to worry. If you know how to use them properly, then you will be knowing how to use the rest of them also. Okay. So that is one thing. Another thing is, why do we need different format specifiers? You see here, I said you this percentage D is the format specifier for integers. Didn't I say you that thing? Yes, percentage D is the format specifier for integers. It means what? See, logically, if you think for a moment, it means what? If you create a hole of type integer, then you have to fill the hole with an integer value. If you create a hole of type floating point number, see, this just tells you what type of hole it is. Now it is a integer. If you write percentage D, if this hole is coming from percentage D, then it is an integer type hole. This is also coming from percentage D, so it is an integer type hole. Okay. So if it is coming from, say for example, if I write now somewhere, uh, say for example, I write now somewhere printf, and then I write, just for the sake of an example, I'm writing this is the value of pi. Okay, I'm writing it in this way. Now you see, if this string is displayed by printf, what will happen here? It will create a hole. Okay, I didn't write, oh sorry, I had to write here f now. Okay, percentage f is the value of pi. Here it will create a hole, and what will be the type of the hole? It will be a floating point hole. Okay, because you are creating the hole with the format specifier percentage f, so it is a floating type hole will be created, and then is the value of pi. Okay, now you see, you created a whole of floating point type. So what you have to do is, as a programmer, if you want to keep everything like compatible, then in that case you have to specify a floating point number here. So you can write there directly the value. Say for example, 3.14 is the value of pi. So in that case, what will happen is, when you display this string, this will be created, you can think of first, and then this first hole will be filled up with the first value that is specified. So only one hole, only one value. So this value will go to the, this hole. So that way 3.14 is the value of pi will be displayed on the screen. You got the point? Yes, I guess. So these are things that you needed to know. Now, if you have understood up to this point, then we are now ready to write code and see like how things works. Okay guys, now we are ready to write some code and check our understanding. This is the basic skeleton of a C program, as you might have seen it many a times. Now here, what am I going to do is, say for example, we have a variable a of type integer, and then we store there's a number 90, and we want to print the value of this variable on the screen. So what we can do is, we can write printf. See, this is printf is a function. Then you have to specify a string, so I'm writing it in this way. Now what we want to like display, so for example, we just want to display the value of this variable a on the screen. So what we'll be doing is, we'll be writing, okay, create a hole and fill the hole with the value of the variable a. That's all. Now if I run this program, then you'll be seeing, okay, my output screen is on the left hand side now. you're seeing that this 90 is coming on the screen, right? I mean, this is the output of this program. So why only 90 is coming? You see, you have written printf percentage d, so it will create a hole. Only a hole will be created, and the hole will be filled up with the value of the variable a, which is 90. So 90 will come here. As a result, you're seeing 90 on the screen. But before moving further, let me, if I can bring it towards, yep, right. Okay. Now, if I run it again, where it will appear? Here. Okay, done. Now that's how it is now printing 90 on the screen. Now suppose instead of writing percentage d, if I write the value of a is equal to. Now, so if I write it in this way, then if I ask you like, okay, what will be the output of this program? Then yes. Now see, from up to this point, everything will come as it is on the screen, because they are not special character. T is not a special character. D, H, E, none of them will be interpreted as a special character. So after printing this much, it will see, okay, this is a percentage D, a hole will be created, and that is the end of the string. And from where that hole will be filled up, the hole will be filled up with the value of the variable A. So as a result, you will see the value of A is equal to whatever it is, 90. So 90. So run the code and check the output. You can see the value of a is equal to 90. Up to equal to everything is coming as it is. Okay. Now say for example, if I write here a new line character, then if I ask you predict the output, then what will happen? What will be the output here? The value of a is, and in the next line equal to 90 will appear. Let's run the code and check. See, the value of a is equal to 90 is coming in the new line, because in the next line. Because why? Equal, see, just before equal to there is this new line character, so as a result the cursor will come here first, and after that again it will go on printing. Got the point? Okay. Now suppose instead of having only one variable, we have two variables. Then what? Say you have this int a, and at the same time you have this int b, and there let me store 87 in this way. Now I could have initialized the variable itself. I mean, at the time of declaration itself, I could have stored 87 there. But just to show you that this is another way of storing. I mean, this they are not different actually, sort of. Okay, it will create and it will immediately store 90. It will first create and then it will store 87 in this variable b. Okay, let's now, I want to print, say for example, both a and b on the screen. So I'll be writing printf, and now displaying a and b on the screen. If it is only the task, then you can write it in this way, percentage d, and comma a comma b. Why did I write it in this way? I mean, see, I want to display the value of a and b. So so this percentage, if you execute this printf, then what will happen? For this percentage d, one hole will be created, and for this percentage d, another hole will be created. So two consecutive holes will be appearing, and the first hole will be filled up with the value of the variable a, which is 90, and the second hole will be filled up with the value of the variable b, which is 87. So 90, 87 will come on the screen, one after another. So you will feel like, okay, it is actually displaying 9087 on the screen. Okay, run the code and check the output. 9087 is coming on the screen. You got the point? Okay, but it is not 9087, huh? It is like 90 and 87 being displayed here, but it appears for us as if it is 9087. Okay, now if you want to give a space, then you just have to write a space here, and then if you run, then it will come like 90 space 87. Or suppose if you want to write here, like, put the label also, like say, okay, this is a equal to this and b equal to this. So if I now run, then it will be more readable. A equal to 90, b equal to 87. So you know, right? I mean, whatever it is that you want to display along with this percentage d, you can display actually. Okay, or means you can use this percentage d in between some text also that you are already displaying. You got the point? So you can write here, for the computer it really doesn't matter if you write here b is equal to percentage d, a is equal to percentage d, and if I ask you what will be the output of this program, now see, when the computer executes it, it will be like b equal to a whole and space a equal to a whole. So it'll coming like, now from where this first hole will be filled up with, it will be filled up with the first value that you specify. So the first value is a. I mean, it is the name of a variable, so it will go to the variable to see what value it is there. 90 is there, so 90 will come. So b equal to 90, a equal to 87 will appear on the screen. So if you run, you will see b equal to 90, a equal to 87. But see, in your program, a equal to 90, b equal to 87. So it really doesn't, printf really doesn't care like where actually you are putting this percentage d. I mean, like whether it is meaning it will be displayed in in a meaningful way, or in some wrong way or something. It really doesn't interpret anything. Only thing it knows that whenever it is a percentage d, it has to create a hole, and once the string is over, it will get a list of values, and from the list of values, it has to fill the holes sequentially, one after another in the order. Got the point? So that way, b equal to 90, a equal to 87 is coming here because you have written it that way. Now here you can write, now it's not b, something equal to something and something equal to something. Run the code. See, that thing is equal to 90 and that thing is equal to 87. I guess now you people got the point, right? I mean, how things are working. Okay. Now say, just to make the things look, make the output meaningful, I'm writing b equal to a equal to this, and b equal to this. Okay, done. Now suppose, let me ask you this question. Say, if I now write the printf in this way, printf, and then uh, say percentage d plus percentage d is equal to percentage d. Okay, now I put a comma here. Now if I want to complete this printf statement in a meaningful way, what do you think, how many values I have to specify here? Yes, I have to specify here 3 values, because I have used here 3 format specifiers. One whole, another whole, another whole. This plus and equal, they are only for displaying as it is. Okay, so here I have to give here 3 different values. So let me give the values like 1, 2, 3. See, it is not necessary that here the list of values should be only only a list of variables. They could be direct values also. Okay, like the way I'm writing here, 1, 2, 3. So now if you execute this program, so if you now execute this program, then what will happen? This particular line, what it will do is, it will be displaying, like suppose this is your output screen. Now what is this? Percentage d is the first thing, so it will create a hole, and then this plus, it is not a special symbol, so it will come as it is. Then this percentage d is a special symbol, so, no, the format specifier, so it will create a hole, and then equal will come as it is, and then percentage d means it is another hole. Now here the first hole will be filled up with the value that you specified first. So 1 will fill this hole, 2 will fill this hole, and 3 will fill this hole. So 1 plus 2 equal to 3 will come on the screen. Correct? Okay, now let's run the code and check the output. So 1 plus 2 equal to 3 is coming on the screen. Got the point? Okay, now say if I write, now instead of writing this in this way, if I write a plus b equal to percentage d, what do you think, how many values I have to specify here? If I run this program, it will not throw you any error actually. Okay, a plus b equal to percentage d. I mean, here you have created only one hole, so the hole will be filled up with the value of this first with this first value. These rest of the values will be sort of unused. Okay, so if I run this code, you'll be saying a plus b is equal to 1. A plus b, you do not you think that this 1 will go to a. 1 cannot replace a, because a is not a format specifier or anything. It will be displayed as it is on the screen, a. Then plus and b, same way, will be displayed as it is. Equal symbol will be displayed as it is. Only this percentage d will be replaced by a hole, and that hole will be filled up with the value of, with this first value that you specified. Although you have specified like 3 values there in the list, these 2 values you're not using, so that way only this 1 will fill the gap, and that's all. As a result, you'll get this output on the screen. Okay, and what will happen, like say if you do not even specify any value, you run the code and check. Okay, here it is an error. Say for example, you specify, say you have 2 percentage d, you must have to write comma and then certainly have to give a value. Say you do not give any value. Okay, percentage d, like this, only this much you write, and then you run. You're getting a plus b equal to 420748. I mean, some these values, you don't know like with what, the computer didn't know with what it has to fill this gap, so it is just displaying you some random value here. Okay. Then say, for example, if you write %d and another %d, two holes are created, but you have specified only the value of one hole. The other you didn't specify. So that way, if you run the code, this one is not a problem. See, a plus b equal to %d. The first hole will be filled up with this first value, no problem. But for the second hole, it is just taking on garbage value. Okay, because you have not specified anything here. The computer will not object when you write it in this way, because it is no as per the syntax. It actually cannot see in future like how many holes you have actually created. Okay, so here it will take accept any valid list of numbers like 1, or you can specify 1 comma 2 or 1 comma 2 comma 3, or even if you want you can write like no list at all. Because see, these holes will be created. Only thing is that when it will try to fill those holes, it will see, okay, if there's any value, there are any values there in the list. So if it doesn't find anything there, it'll simply fill these holes with some garbage values. So that way, syntax wise, your program is right. But if you see it from the point of view of logic, then certainly it is not right, right? So that way you can say like this is not a syntax error, but it is a logical error. Okay, so you didn't mention the values there properly, so that's why this sort of output is coming. So if you run the code now I have specified valid list, and like everything is matching now. So 12,23 is coming on the screen. Okay, guys, I mean, that's how you can use these format specifiers. Now, till now, I have explained you, I'm demonstrating you the use of %d only. Now, whatever I said, about %d, everything is true for all the other all the other format specifiers also. But then also, let me show you now some examples with floating point numbers, characters, and doubles. So we have a floating point number, float a equal to say 3.14123. And then I want to display it say on the screen. So for that reason, what will you do is printf. If you want to display floating point number, just to make it more readable, I'm writing a equal to %f. And then see, since you are displaying a floating point number, you have to write there %f. That is, you want to create a floating point hole first, and that hole should be filled up with the value of the variable a. So now if you run the code, you should be able to see, okay, a equal to 3.141230. This 0 is coming from somewhere, right? I mean, it is displaying you after the decimal 1, 2, 3, 4, 5, 6 digits. Okay, so that's why this 0 is coming. You can think of it that way. Okay, now see, if you do not want say to see the output up to 6 digits, say only two digits you want to see. Okay, up to two digits, precision you want to see. So for that reason, what will you do is you will write there 0.2f. So if you now run the code, then you'll be seeing, okay, a equal to 3.14. But suppose if I write here 3.145, okay, let's see what will be the output. Now output is 3.15 up to two digits precision. If you consider 3.14, I mean, here it has to truncate this part. Now since this part is greater than 0.5, I mean this number is greater than 5, greater than or equal to 5, this will add 1 here. So 3.15 actually. Okay, so that's why coming 3.15 here. So if this number is smaller than 5, say 3.142 now, after 4, the next number is 2, which is smaller than 5. So if you run the code, it will be displaying 3.14. Okay, so now you see here, this why only two digits are coming. How many digits you want after the decimal point, that you can specify by writing 0.2, I mean point n. This n is the number of digits that you want to print after the decimal point. That's something you will be using actually whenever you are displaying floating point numbers on the screen. The same is true for long floating point numbers, that is double also. If you write now this variable, if you declare this variable as now double, as I said, no, these double and floating point numbers, like the nature of the numbers are same, only thing is that the sizes are different. So 3.1423 you can store either as double or a float. Only thing is that double will take more memory than float. Okay. Now printf a equal to %2fa. If you run this code, I guess it will work. 3.14. See, although this a is a double variable, but you are displaying it as a floating point number, so no problem, it will display the output. But the actual format specifier is long float. Here you will not see much difference in the output. A equal to 3.14 will be coming. So that's another thing. Okay, and then so now what is the other data type left? That is character. Now let's do some experiments with character. Okay, say for example you have this character variable, say let it call a, and equal to, say, now what is a character variable? I said, like, if the if the data is a single character, then it's a character type data. Now single character means, say for example, a, but can I write a on in this fashion? Now see, if I try to write a in this fashion, what it is doing is it is objecting. Actually, see, this red mark is coming. If this red mark is coming, it is the feature of Visual Studio Code Editor. Okay, I mean, but suppose you are writing the code in Notepad editor, you will not get this hint. But then also you should realize that writing it in this way is wrong. Why it is wrong? Actually, see, if you write character a, why it is wrong? Okay, let me give you an example first. Say for example, I write int, I declare a variable, say integer a, capital A, and in that case I store now capital A is equal to 90. Now I declare another variable b, and in that variable b I store capital A. Okay, I'll be doing it in this way. Now you see, if I write b is equal to a, there is no problem. Why there is no problem when you write b equal to a? Whenever you write b equal to a, it will see if there is a variable. See, whenever you write any name, any, like, these are called as your identifier name or identifiers. Okay, in general. So whenever you are writing a name, then it will be assumed like it is a variable. Actually, now here it will be, this a will be assumed that okay, there is an identifier or there is a variable there, and that variable has some value. So whatever it is the value of that variable, it will retrieve, the computer will retrieve that value and it will put it on this left hand side variable. No problem, right? So int b equal to a, if you write, and here at this point if you print, logically if you follow, although I have not said you much about this equal symbol and when you write something like this what will happen, but then also you can make a guess, right? What it is doing is it is storing the value of a in the variable b. So if I now print a equal to percentage d and b equal to percentage d, two holes I have created. The first hole I want to fill with capital A, and the second hole I want to fill with lowercase b. Okay, so done. Now if I execute this program, you'll be saying me, okay, a is equal to a, capital A, capital A is 90, so 90 will come here. B equal to a whole, which is the value of the variable b. Now what is there in b? In b you have stored the value of a, which is 90, so 90 is there. So as an output, if you run this program, you'll see 90 and 90, no problem. Now, why am I telling you this story? You now see here, wherever I have written this capital A, it is not a problem. Every time I write a capital A here, or every time I write a name, something which is not a keyword or which is not a inbuilt function name and which is not within double quotation, they are actually interpreted as a variable, isn't it? So if that variable is there, there is no problem. But if I want to write here now, say c is equal to 90, now it is a problem because this c is not a variable here. See, c is not a variable. If I try to run this code, you will see that c undeclared, first using this function c is equal to 90, c is undeclared. You know what is the declaration of a variable? It is the creation of a container. So since we have not created any container whose name is c, that's why these c undeclared error message is coming, and this is the syntax error. I mean, your syntax is wrong, your program itself is wrong, your program cannot be compiled to its machine code. Okay, now see, it means what? Whenever we write some some text, as I said, no, which is not a keyword, which is not a function inbuilt function name, or which is not within double quotation, they will be treated as variable names. Okay, now let's get back to our previous point, like where I declared a character variable and where I tried to store this a. Okay, I tried to store this a. Now now you should realize why this thing is wrong. If I write character a is equal to capital A, And it means what? This capital A, if I run this program, you see, you will get the same error message. A is undeclared. A undeclared. First use in this function, character A equal to A. It means what? What the compiler is thinking this A as? It is thinking this A as, okay, it is a variable which should be there in the program, which should be declared in the program. But since you have not declared in your program any variable whose name is A, it is this error. But actually, you do not want any variable whose name is A. What you want is, you just want to store the character A, the letter A in the variable A. That's your goal. Now, if it is your goal, then you have to do something extra to to express your intention. And that extra is, you have to put this A within this single quotation, not within double quotation. Remember it. You have to put it within single quotation. So if you want to represent a single character, literal single character, as a value, if you want to use it, then you have to write that character within single quotation. Okay. Now, if it is the case, now in the variable A, you have stored the character A, and then you want to display it on the screen. How you are going to do it? You are going to display it like printf, and then within double quotation, see, you want to display what? You want to display a you want to display a character, and then that character should come from the variable A. So that's why printf %C and A. Now, if I run the code, you can see this A is coming on the screen. Got the point? So if it is a character that you want to display, then you have to write these percentage. You have to make use of these, these character format specifier %C. Got it? Now say this is your printf, but here the way you can write something like this: printf percentage D. Instead of writing a variable here, you can directly write here a value, right? The same way you can write. See, if I run this program now, say these two lines are not there, just to make the things clear. I run this program now, you can see that 1232 is coming on the screen, because this will create a hole. The hole will be filled up with 1232. The way you can write it in the way you can directly specify integer value for %D, same way you can directly specify character value for %C. Say I want to display the character X. So what I'll do is, I'll write I'll write this X within this single quotation. You cannot write X here in this way. If you write %CX, what it will assume is this X is a variable. But since you do not want that, if your intention is, you are not talking about a variable whose name is X. You're talking about the character X. So for that reason, you'll be writing here this X within this single quotation. If you run the program, you will see X will appear on the screen. Great point? Okay. Okay, now what? Okay, more or less things are done. I guess people have understood like how we can display integers, floating point numbers, characters, and doubles on the screen. I mean, those values of those variables on the screen. And that's all, I guess. Let me tell you one more thing about this character, and that will with that I will finish the video. And the thing is, say for example, this character. Now I said in my, when I was explaining you about this character data type, I said that this character is nothing but the size of a character is 8-bit. So if you see here, these characters, although I said like you can store a character, how it will be stored in the computer. What are these letters are actually? These X, Y, Z, A, B, C. What are them? They are nothing but each of these letters like A, B, C, D, or capital A, capital B, capital C, capital D, or those digits like 0, 1, 2, 3, or those symbols like plus, minus. So whatever you see more or less on the keyboard, for all of them, there is an equivalent number. So for these A, the equivalent number is what is that? For A is equal to 97. For this B, it is 9, obviously 98, and C is 99, like that. For capital A, it is 65, 66, 67, like that. For 0, I guess it is 48, 49, 50, like that. For plus, there will be a number. Okay, I'm not sure exactly what that number is right now, but I guess you people got the point. Each of these characters are represented by a number. It means here, if I write here, say A, okay, let me show you. If I write here an A and I display it, so if you see, it will display this character A on the screen. Now I said you that each of these characters are associated with a number, and what this A is associated with, the associated number means the corresponding number of this A, letter A, is 97. So it means what? I can write this letter 97 here. Sorry, I can write this number 97 here. So it means what we're doing is we are displaying 97, but in the form of a character. So if you display 97 in the form of a character, it will display you, see, the A. Okay, so if you want to display a number, I mean if you want to display a character, you can directly write the character value within this single quotation, or what you can do is you can directly write the the ASCII code of the character, this ASCII number of the character. These are called as the ASCII number. No, each of these characters will have some ASCII number. So here if I write now 65, then I run the code, you'll see a capital A coming on the screen. If I write here 49, and if I run the code, you will see a 1 coming on the screen. From fraud, you might be thinking, okay, I'm displaying 49, but why is it displaying me a 1? Because you see this 1 ASCII number is 49. So this 49, if you print in the form of a character, then only this 1 will come. If you print 49 in the form of an integer, it will display you 49 as it is. You got the point? Right? So 49, if you display as integer, 49 will only come. But if 49, if you display as a character, then it will display you 1 on the screen. Okay, guys, got the point? So that much only, I had to tell you, we just have started learning like how we can, display values of variables on the screen. Just to finish the video, say for example, I have a variable A89. I'll just leave this thing as, sort of for you. You just try to answer these questions by yourself to check your understanding. If you can answer, then things are good. You people have understood it. Say, for example, you have a float b is equal to 90.09, and you have character, say, x is equal to the letter A, and you want to display all of them on the screen. Okay, your output should be, say, A is equal to 89. In the next line, B is equal to 90.09. Say I actually store in B 90.098767, but I want my output to be 90.09. So for that, to make your task easy, I write here the number as 2. Okay, so 90.09 I want my output, say, and then this third line should come as x is equal to capital A. So suppose this is the expected output, and these are the declaration already done. Now what printf statement will you write here that displays this output as it is on the screen? Try this thing by yourself. And okay, guys, then that much only in this part of the video. I'll see you guys in the next part of the video. So what will I do in the next part of the video is I will be talking about I'll be talking about this thing actually. See, where sorry, I'll be talking about this thing. Like I showed you how you can use these format specifiers to display values of variable on the screen. Okay, so this part is told. Now I'll be telling you how you can use the same format specifiers to take input from the from the user, or how to how you can use these format specifiers to read values from the keyboard. So that is the that will be the content of the next video. So stay tuned, and if you can subscribe this channel so that you get the notification, like as soon as I upload my videos. So that much only in this part of the video. See you guys with some new content in the next part of the video. Till then, have a nice day.